Now we look at the case when we want to model two random variables at the same time. So far, the random variables were not dependent on each other, were not related to each other in any way. But what happens when they are related? Then calculations become slightly different. And so we're going to talk about conditional, joint, and marginal distributions. We just use probabilities to describe outcomes involving more than one variable at a time. And we need to be able to measure what we think will happen to one variable relative to the other. And I'm just going to introduce general notations here, and we're going to talk about what they mean, and we're going to see a specific example in a couple of slides. So when we talk about joint distribution, we have two random variables, x and y, and we want to understand what happens when x and y are modeled together. Then we do it using joint distribution, and we write p of x equals x, comma y equals y, which is a joint probability that x random variable takes value of x and y takes value of y. So you see this and here, joint probability is essentially one and the other one happening at the same time. And the next concept is conditional probability. And we denote the conditional probability by this vertical bar. So probability that x equals x, given that we know that y equals to y, is the conditional probability of x given y. So let's look at an example of conditional probability. What's the probability that we will see rain today, given that it was raining yesterday? And we know that sometimes rainy days follow each other, so maybe rain today and rain yesterday related in any way. So knowing that it was raining yesterday might tell us about what would be the probability of seeing the rain today as well. And then last concept is marginal probability. Again, that's actually it might seem a little bit abstract at this point. It's just the probability of a single variable, which we can calculate by knowing joint or conditional probabilities. And we will see examples of how to do those calculations in a few minutes. There are a few rules associated with marginals and conditional, and joint distributions. So probability of joint distribution x and y is just the probability of y given x times the probability of x. Again, we'll see example of that in a few seconds. And there is a symmetry. Since x and y are symmetric, we can say it's the same as probability of y times the probability of x given y. Okay, and we can calculate the marginal distribution from the joint distribution by just summing across the other variables. So if we want to calculate marginal distribution for x, then we just have to take the joint distribution and sum across all possible values of y. Again, we will see the example of it, and those abstract formulas hopefully will make much more sense in a few minutes. So here's